Mark Thompson here. Thank you for listening today. Welcome to Innovate with Ease, Episode 3, The Motor of Innovation, Part 2. In Part 1 of The Motor of Innovation, we set out to explore our primary instrument of innovation, our brain, the apex of our central nervous system where information is integrated within biological tissues. This integration occurs in the cerebral cortex, the surface of that large wrinkled mass of neurons at the outer surfaces of the brain that facilitate the majority of our cognition, our consciousness, our sensations, our mental associations, our decision-making, and some of our reactions. Our cerebrum processes our somatic senses, our proprioceptional senses, our visceral senses, our auditory, visual, olfactory, and gustational senses. And it compiles senses which produce abstract cognitive sensations. Sensations like wonder and fantasy and adventure and intrigue and hundreds of others, each sparking emotions and curiosities, and sometimes physical reactions like smiles or frowns. Our cerebral cortex enables us to decide motor movements and to plan life. It's where our conscious cursor of the mind exists, and it's where the majority of our creativity and innovation take place. We looked at the basic cellular biology of neurons and their vast felt-like structure of synaptic connections with the gray matter of the cerebral cortex, the phenomenally active bits and bytes that are key to our cell-aware logic system. In this episode, let's look more into our brain. These deeper regions that lie under our cerebrum need to be recognized and understood so that we can maximize our potential for developing great creations. Today, we'll uncover what's underneath and discuss how each inner brain region impacts design, creativity, reactivity, and how they impact our own selves. And before we start, please slide over and tap or click the like button of this video, and please subscribe to the channel to get the entire series of shows to come. Clicking that notification bell will let you know that another show is ready to play. If you haven't already, please go back and watch Part 1 of The Motor of Innovation prior to this episode. Once we have a fair understanding of the brain's intricate neural wiring, we'll be better prepared to understand the mind that rides upon the brain, giving ourselves a solid framework to use our minds strategically for all the creativity and innovation to come. This is an important foundation because our minds truly are the only thing that we use to innovate, and our minds are the only things that we use to encounter others' creations. So if we create something, we should extend our imaginations to predict how someone else might encounter our creation based on how their brains are wired and allow us to better predict likely outcomes. Hopefully outcomes that we want them to experience, allowing our creations to be noticeable, useful, intriguing, desirable, excellent, and successful. Recall from the previous show, the human brain forms very early in the fetal development. It starts as a neural plate, which then forms into a neural tube. From there, it develops into a working brain with a spinal cord with peripheral nerves that extend to far reaches of the body. And this neural system continues to mature as we approach adulthood. Our brain depends on our body. The brain develops so that it can, to the best of its ability, encounter this strange and potentially dangerous universe outside of our craniums, and react in such ways that the brain can ensure its own survival, and ensure the body's survival. And so, these inner structures of the brain underneath the cerebrum maintain the body so that the body can serve the brain. Your creations, or creations that other people make, for better or for worse, could produce effects on the body and therefore the brain. These inner brain substructures and their interconnected wiring are necessary to understand for understanding the brain as a whole. So let's look inside. If we start below and examine the spinal cord, we see bundles of extremely long neurons extending to everything. Some of these neurons are efferent, meaning they send signals away from the brain towards the far regions, generally to muscles. And we have neurons that are afferent, meaning they send signals from far regions, generally sensory nerves, toward the brain. To and from. Command and feedback. When the brain moves a muscle, efferent neurons send those signals from the brain to the muscle. When the skin encounters something physical and mechanical, afferent neurons send those signals from the skin areas to the brain, which then produces perception of touch sensation. From these peripheral areas of the body, to the spine, up the spinal cord, and into the neck, we enter the hindbrain, the very bottom of the overall brain structure. All of these efferent and afferent nerves pass through this bulb-shaped stem of the hindbrain called the medulla oblongata. Medulla means innermost. Oblongata refers to the oblong shape of the stalk-like raceway of neurons running between the spinal cord and the upper part of the brain. Even though this bulb is mostly a neural pathway, this area does have functional synaptic neurons. And since the medulla is closest to the body, these synaptic neurons manage the most vital functions of the body, the things that need attention above all others. A living brain cannot exist without frequent supply of nutrients, minerals, water, oxygen, balanced chemistry, waste handling, and general homeostasis. These are mostly facilitated through our blood supply. So the medulla oblongata commands heart rate, circulation, respiration, blood pressure, all of these extremely vital things, ensuring that our blood actually supplies these life-sustaining elements. Within the spinal cord, peripheral nerves branch out between vertebrae, reaching to various regions of the body. But within the head and neck above the spine, other cranial nerves branch out from the medulla oblongata to areas of the head and neck such as the tongue and throat muscles, vocal cords, saliva glands, and others within your upper regions. And through these cranial nerves, the medulla oblongata manages autonomic actions such as coughing, sneezing, yawning, swallowing, and vomiting. Reflexes that you need for immediate health remedy situations. If your body cannot perform these vital functions, you cannot live. And so the deepest base of our brain serves all of that. That frees the remaining parts of the brain to do other things. Above the medulla oblongata in the hindbrain is another large bulb called the pons. This neural mass includes crisscrossing and traversing conduits of nerves connecting neurons from the upper regions of the brain through the medulla and the spinal cord below, and to the cerebellum behind it. We'll talk about the cerebellum later. Leading from the front of the pons are motor and sensory nerves that extend throughout the head, like the face, the jaw, nose, ears, and neck. This small hindbrain bulb is kind of a miniature spinal cord of sorts, serving areas of the head and neck. But the pons is more than that. The pons acts as a heavy traffic intersection of neurons going here, there, and everywhere throughout the body and the brain, forming crisscross pathways. The pons also includes a bit of gray matter with synaptic connections for directly controlling a limited range of actions, such as facial expressions, chewing, hearing, balance, blinking, eye focusing, and tear production. Named after the Latin word for bridge, the pons directs neural signals to the appropriate areas of the brain, linking the upper to the lower. When you move or feel something on your right side of your body, those sensations and voluntary decisions occur on the left side of your brain. The crossing of neurons of left to right happens here in the pons. Why? It's a consequence of how the neural system was formed in early fetal development. Consider this for your creations. Since the muscular process of producing a smile comes from your pons, if you aim to design a creation that ought to produce a smile, neurons in someone else's pons will need to be aroused, stimulated by the purposeful design features of your creation for that smile to express. Moving upwards, attached to the top of the hindbrain stem, we have the midbrain. About the size of the end of your thumb, this small neural package is associated with functions such as vision, hearing, motor control, sleepfulness and wakefulness, arousal, and thermal regulation. The midbrain links to upper parts of the brain with the rest of the brainstem. The midbrain has direct connections with the eyes and the ears. Since potentially dangerous threats might exist within eyesight or earshot, synaptic gray matter in the midbrain can process auditory and visual information and trigger direct reflexive actions based on what unusual surprises we might see or hear. The midbrain can control eye movements, pupil dilation, head muscle movement, and motor control, all meant to instinctively and cautiously react to abrupt things in the environment. The midbrain also regulates moods, pains, alertness, and breathing. This whole region of the midbrain and hindbrain are what some refer to as our reptile brain or primitive brain. It's the core that keeps us alive every second of every day. If this region of the brain were to encounter damage, one might struggle to stay alive even for seconds. So these parts of the brain are critical to protect. And as we move further upward, we enter the regions of the inner brain. And here's where things get pretty complex. I won't go too far into the complexities here, but let's look at what's here as simple as we can. I highly encourage you to learn more about this region of the brain on your own, studying any available resource. You can also visit the playlist The Brain of this Innovate with Ease YouTube channel, and you'll see plenty of wonderfully informative videos of these deep and very mysterious interconnected areas of the brain. At first learning, these subcerebral structures may not seem to relate with your ability to innovate and create, but they do. They really do, in the sense that these areas affect how you live, how you sense, how you see, how you hear, how you move, how you balance, how you react, how you emote, how you maintain attention, how you motivate, how you perform, how you recollect, how you energize, how you jerk, how you rest, and so on. Creations that interact and engage with these areas of the brain can cause strong reactions with observers. So if you want your creations to draw pure interest and focused interaction, listen up. Remember, we're here to understand the brain's wiring so that we can understand roughly how the brain works as a whole, since that's where our minds live. Our creations can be intentionally designed to interact with others' minds. In essence, interact with brains based on how those brains are specifically wired. This inner region of the brain is much of that intricate and sparky wiring, and it's common in all of us. This complex wiring helps information integration become possible. And it's all done via cells and connections amongst cells, which is really just amazing. So let's look at this inner brain. Positioned atop the midbrain above the brainstem, we have a coral neural area we call the diencephalon. This core is comprised of complex packages of neurons that are surrounded by one of the many ventricles of the brain. We've all heard that our hearts have ventricles for pumping blood, these open spaces filled with fluid. Well, so does our brain. Aside from blood supply, your brain has its own fluid system to keep itself healthy. Your spinal fluid is part of that overall fluid system. These fluid-filled ventricles are interconnected by internal canals. In this diencephalon surrounded by one of these ventricles, right smack in the center of our brain, we see the thalamus. Many refer to this area as just the thalamus, but it's really more than that. It's a thalamus mass itself, a metathalamus, an epithalamus, the subthalamus, and the hypothalamus. Put very simply, you can think of the diencephalon as being a pre-thinker and a network router of sorts, a gateway to the mind, all performed by its developed neural wiring, sending particular signals from the brainstem to and from appropriate regions of the cerebrum above. The lobes of the brain that we learned about in the previous episode, the frontal lobe, the parietal lobe, the occipital lobe, and the temporal lobe, include neurons that extend axon branches downward and into the diencephalon to where they then reach everywhere else. All of these primarily run through the thalamus. The thalamus in this diencephalon acts as an attention filter of sorts. Imagine all that simultaneous external stimuli that constantly bombard your sensory field all around you, all at once, all the time. Your body never knows when a true threat is present, so it's built to always scan the environment. The thalamus works to limit where your attention should be focused, preventing your brain from being overwhelmed, focusing your brain's energy and attention to where it likely needs to be directed. The thalamus helps you quickly dismiss certain senses that identify as non-threats using associated memories of familiar occasions. It keeps you awake, alert, focused, and aware. This thalamus, which are really two bound left and right thalami branching out to the left and right hemispheres of the cerebrum, are shaped like a small pair of cat paws and are subdivided into functional neural centers within. One neural center is involved with emotional episodic memory. So when you encounter stimuli, you freely recall something from a previous experience and you feel happy or angry or cherished or embarrassed or loving or remorseful or inspired or guilty. These emotions are generated in your thalamus, and reactions propagate throughout your cerebrum and throughout what is called your limbic system, which surrounds the thalamus. So if you design a creation that might include emotionally rich features, a beholding observer might engage with your creation, and senses generated by those features might plant themselves into episodic memories within their thalamus, and the observer will carry those memories with them, possibly becoming formative for the rest of their lives. And that's just a sliver of the thalamus among its many other neural segments. Other parts of the thalamus relay motor signals and sensory signals, hearing, taste, sight, and touch, but not smell, between your body and your cerebrum. It's a sensory manager that integrates these sensations before they're sent to the cerebrum for processing cognitive sense of them. The thalamus can process those sensations so that they can be perceived as related to each other and help you best construct comprehension of the real world around you, whatever that is. You see what you hear what you see what you feel what you're looking at. Those things are supposed to connect for the brain to make sense of them. This real-time sensual integration helps our mind create some sort of understanding of the world that the brain is always blind to. Behind the thalamus is an epithalamus, acting as a connection between the limbic system and other areas of the brain. The limbic system is something we'll talk about in a few minutes. The epithalamus includes a small mass called the pineal gland. When aroused, the pineal gland secretes melatonin, inducing drowsiness, causing your mind to sleep. It regulates circadian rhythms, the frequency and stability of your sleep. If you design a creation that is warm and soft, slowly rhythmic and dreamy, your creation could stimulate that pineal gland, causing an observer to become drowsy. And underneath the front of the thalamus hangs the hypothalamus. This is a group of specialized neurons that connect with a pituitary gland underneath your brain. The pituitary gland is the command center that controls many of the body's hormones. The hypothalamus maintains general homeostasis of the body. Our body is a complex chemistry system, and its assorted chemical processing needs balance for the body to sustain. These neurons of the hypothalamus provide your senses of appetite, of thirst, of satiation. When your body grows, how it changes, how it reacts to the environment, how it prepares for reproduction, the hypothalamus will influence the nearby pituitary gland to secrete several types of hormones to prepare the body for those needs. This is the command center for the chemistry of the body. The subthalamus is a small region underneath the thalamus that links with what is called the basal ganglia surrounding the thalamus. A ganglia is any region that contains a grouping of synaptic connections. Basal ganglia are synaptic regions along the inside surface of the cerebrum, and these neurons regulate things such as fine motor movement. They're linked directly to the primary motor cortex of the frontal lobe of the cerebrum above. So when you carefully use your fingers to craft delicate details of a creation, your thalamus, subthalamus, and basal ganglia are involved with that activity. Exercises like yoga challenge the basal ganglia for exercising fine control of many skeletal muscles throughout your body. Healthy neurons in these areas of the brain directly contribute to excellent creative detailing. Just look at this basal ganglia. These weird, loopy, web-shaped formations capture the thalamus and reach us to the limits of the surrounding limbic system. So what exactly is this limbic system? I like to call it the oh snap system. Our brains and our minds live in wet, dark skulls, and our brains are aware that there exists a strange outer universe, a potentially dangerous and threatening universe. Our brains are responsible for protecting us against any and all threats present in that surrounding universe. And so, our brains are equipped to deal with that, automatically. This reactionary equipment, with all of its intricate wiring and automation, is our limbic system. Limbic means ring or border or edge in Latin. It's not really a thing per se in our brain, more than it's just a group of neural nodes connected along a loop surrounding the inner ventricles of our brain. It's a surrounding boundary of neural groups and connections between the diencephalon, the thalamus area, and the telencephalon, the cerebrum above. This limbic system is the emotional, reactive, and memory processing center of our brain. Here, everything is connected to everything, and everything reacts with everything automatically. This was once called the rhinocephalon, meaning the nose brain, as early researchers deduced that it was centered around smell. It kind of is, but more is understood about the limbic system today. Many instinctive decisions are made automatically within the limbic systems, sometimes causing you to react before you consciously decide if you should react. In other words, this part of the brain deserves close study because designing creations that engage with the limbic system can cause strong influence and potential danger. Remember, this is the oh snap system, so let's take a look. A very reactive feature of the limbic system lies at the tail ends of the basal ganglia, the amygdala, one on the left and one on the right. These almond-shaped and almond-sized neural clusters lend to their name amygdala, which literally means almond. Nerves from the amygdala lead from your eyes and from your olfactory bulb in the sinuses above your nostrils and extend across the basal ganglia to the visual cortex, the olfactory cortex, and the frontal cortex of the cerebrum. When something startling happens in your visual or aromatic fields, the amygdala is the first to notice and the first to react. Oh snap! The amygdala will kick in with defensive measures before your cerebral conscious even has time to notice. Sometimes your amygdala and your conscious mind are at odds with one another, and this is because how each are wired to the senses. The wiring to your amygdala is much shorter than the wiring to your sensible conscious, so maintaining your civility can be challenging. The amygdala is your fight, flight, or freeze trigger. It's where distrust, fear, aggression, and resistance are centered. If you want to create an epic rated R thriller movie or produce an effective horror-based video game with jump scares, or if you want to overcome an attacker, or if you want to design an effective fire alarm, or if you're a scrupulous, malevolent politician, you'll hone in on an observer's amygdala. You'll push their instinctive fight, flight, or freeze reactions. It's not all negative though. The amygdala plays a strong role with positive emotions too, like joy, surprise, and elation. When your favorite sports team scores in the last second of a critical game, your amygdala kicks right in. Oh, snap! So handle these particular neural groups with extreme care, caution, and responsibility. Up above the basal ganglia is this overarching structure called the cingulate gyri. Left and right, these ropes of neurons route signals associated with memories and emotions. They also handle pain perceptions, and they direct these signals elsewhere accordingly. And they compile incoming senses and provide a sense of things that are off. When you hear or feel something in the environment that something doesn't seem to look right or doesn't make sense, something that contradicts a pattern, if something is missing, if it looks illusionary, if it doesn't meet expectations, the cingulate gyri grasps that realization, forces attention to it, and helps to unravel these sensory oddities. If you see a dog at night, and then realize it's actually a garbage bag and not a dog, if you hear a wrong note in music, if you see a soldier standing out of line, if you hear someone misspeak, if you see a misspelled word, if you see a mysterious red dot, all these little idiosyncrasies are your cingulate gyri at work. Magicians create perplexing oddities purposely intended to distract observers. They prepare a magical illusion, a design creation, and then reveal it when the observers lose their temporary attention. All of this purposeful distraction targeting the cingulate gyri. This purposeful, off-pattern, something is out of place method, intentionally calling out for noticeability, is sometimes strategically used in quick advertising all the time. Advertisements are design creations, and making noticeable features within them are innovations. And they're designed to stimulate your cingulate gyri. And looping around and beneath the cingulate gyri, beneath the basal ganglia, we have the hippocampus, which kind of looks like a worm or a seahorse. Hippocampus actually means seahorse in Latin. Memory formation, processing, consolidation. The hippocampus converts short-term memories into long-term memories based on the perceived impacts of the sensual experiences. It's your mental time machine. It's also your spatial navigation memory, providing your natural awareness of your spatial environment anywhere around the world. Your house, your dog walk, your neighborhood, your run path, your town, other familiar places. It's your own perceived map of the world for anywhere you've ever been. Your guide for traversing the world and providing your familiarity with whereabouts. It's your cognitive map, your visual representation in your mind of specific land features, landmarks, places, and routes. It also maintains visual memories of common features of places. This helps you to construct your own ability to wayfind your way around if you're unfamiliar. If you walk into an unknown building, you can still find your way around because based on previous experiences, you know to look for areas like lobbies. You know to look for signs and elevators and doors and stairs and familiar expected things like this. Certain creations can be designed to work effectively because your hippocampus is reactive to them. So people who design common signage and things like for navigation are triggering your hippocampus. This is partly why certain types of video games work so well, because the moving background graphics with landmark features connect so well with how the hippocampus constructs cognitive models of the game environment. This allows you to easily perceive your way around, even if it's a video game. It's amazing that individual cells in your brain are dedicated to hold on to episodic memories and to represent familiar places in the world. So always keep those cells healthy. Just in front of and above the hypothalamus, we have the septal nuclei, which include the nuclei accumbens. These left and right nodules are the brain's reward center, another high-risk component of the limbic system. This little area produces dopamine, a neurotransmitter that produces senses like enjoyment, satisfaction, pleasure, bliss, fulfillment, relief, vindication, contentment, championship, nourishment, refreshment, all rewards for perceived good behavior. Healthy levels of dopamine help us with life motivations and the pursuit of desires. It boosts our decision making and the chasing of our goals. But as I mentioned, it's also high risk because the nuclei accumbens can also be abused. Overstimulation of this area can lead to addictions, sometimes dangerous addictions. The pursuit of dopamine can be so enticing that these neurons will prompt decision-making parts of our brain to over-pursue activities that lead to the secretion of dopamine, sometimes to the body and brain's detriment. Other areas of the nuclei accumbens prompt the mind to hold back, kind of the opposite of pursuance and chase. So sometimes this area can cause the brain to be in a fight against itself, kind of a measure of balance. Remember, the brain is keeping you alive. It is promoting its survival in the surrounding environment, guarding you against its occasional oddities. To survive as a human, you need to eat, drink, thrive, cooperate, and compete with others, reproduce, and bring up offspring. This part of the limbic systems help you do all of that while keeping you on track and keeping you from getting off track all at the same time. But if you have easy access to any of life's vices like rich food, alcohol, drugs, money, pornography, passive enablers, this little bit of brain has the potential to destroy you. These neurons can counteract with the frontal cortex and produce irrational decisions. But the nuclei accumbens can also save you when you are healthy. Designing creations that target sensations felt by the nuclei accumbens can produce the most effective reactions of all. They're very reactive to things like exercise, sex, food, and music. If you want your reactions to have notice, stark notice, and produce certain reaction, if you want your creations to have mass participation, you'll create features that react with the nuclei accumbens and possibly the amygdala as well. But do be very careful when doing this. You can unintentionally cast your observers into abnormal, unhealthy, and sometimes compromising and dangerous situations. But they can also produce greatness if you design and present creations thoughtfully and considerately. Study this area of the limbic system with great care. Every area of the limbic system is connected with everything. It's like a charged roller coaster. These limbic parts are connected with the midbrain and the upper brain. When I spoke of the brain's wiring, this is part of that intricate wiring that I'm referring to. The nuclei accumbens connects with the basal ganglia and the thalamus and the hypothalamus. The reward center triggered by senses can produce dopamine, which can cause the hypothalamus to produce oxytocin, also known as the love hormone, which gets distributed across the brain and body. The right amount of oxytocin can produce the feeling of goodness. For instance, if you design features of a creation to include familiar features that remind us of a cute little baby, an observer's brain might likely treat that creation with a certain adoration and cause the release of hormones throughout the body. Quite the reaction. See how this works? Similar to the primitive lizard brain as mentioned before, some call this middle part of your brain your Labrador brain. While your lizard brain is maintaining the vitals of your body, your Labrador dog brain is maintaining the primal responses to the surrounding environment, providing you instinct and insight to survive. Your Labrador brain drives your 3 F's of basic survival. Your reactions of fear, that is fight, flight, or freeze. Your drive to feed, and your drive to the other F word, reproduction. It's your happy, loyal friend who keeps you alive and keeps you going in this crazy world. What a good dog. Treat it well. There's one more area that needs mentioning. Let's follow our wiring back to the hindbrain. There's a nice little secret back there hiding in plain sight. You have a free bonus brain. That's right. You have an extra free cerebrum back there connected to the pons. This free brain is called the cerebellum, which literally means little brain. Think of this as sort of a graphics add-on card connected to your computer. A free brain that you can use for very complex things. Your body is a very complex structure of skeletal muscles. Coordinating and moving all those muscles to perform any mechanical task can be very involved. Your cerebellum handles all of that tedious complexities. It takes a lot of neural power to pull it off. For instance, through your prefrontal cortex, you might make a decision to sign your name on a piece of paper. That decision propagates to the motor cortex, which arranges signals to command the motoring activities of signing your name on a piece of paper. But performing the actual motion of signing your name can involve several dozens of muscles all needing to act in balanced concert. Depending on how your body might be positioned at that moment, the muscular coordination might involve your entire body. The motor cortex sends these command signals to the cerebellum, that free brain. The cerebellum then assigns each of the necessary muscles, dozens of them, their very specific signals, all simultaneously, all coordinated in time, feeling the responses of the afferent neurons, all resulting in a fluid, toned, continuous motion, allowing your body to produce a beautifully written signature on a piece of paper. The same coordination is necessary for walking, for running, for dancing, anything that involves coordinated and toned body movement. So let's summarize. All of these lower brain features are critical to life and survival for the creatures that we are. And these features are common in all of us. They're tied directly to our sensory parts and to our muscles. Because of that, these brain features are very reactive and responsive, sometimes so reactive that our bodies respond before our thinking brain parts have time to ponder, sometimes causing our thinking brain to wish we hadn't done what our reactive brains has decided to do. This neural reality translates into the designs of our creations. When our sensory parts encounter a creation, they will read the features of the creation bit by bit, especially the noticeable bits. Our inner brains will determine quick interpretations of the designs of those features in terms of survivability or thrivability, react accordingly, and pass on information to our cerebrum, that human brain, for deeper interpretation and decisive reactions. Then process things like cognitive sensations and emotions and moods and desires, and sometimes pass signals onto our cerebellum to make us do something physically responsive. The designs of our creations matter because it's our brains that are wired in such ways to react to them. That wiring often makes reactions and responses predictable. So the more you understand the brain, the more effective you can be with design preparation and selection, the more creative you can be, and your creations will perform more successfully. So keep studying the brain and its many parts, its many connections and extensions. But for all of this to work optimally, recognize that our brains do not just sit there and metabolize. They're not just squishy blobs of organized chemistry. These vast, organized, and interconnected synapses, some developed, some innate, lend to something we call the mind. And the mind, which rides upon the brain, is what we will visit next. How this chemistry mass and its many neurons come together to establish this thinking and reacting unit. It's the thinking capability and activity that innovates. The more we can understand it, the more we can innovate with ease. So what are our general takeaways? What can we do today? How can we make a difference knowing that our brains are the motors of innovation? Knowing that the brain is a physical part of your body, knowing that it involves cellular biology, knowing that it's a chemistry system of molecular biology throughout, knowing that it involves energy to operate, knowing that it is absolutely central and critical to nearly everything, I recommend focusing on how you nourish your brain, how you protect your brain, and how you subject it to nearby environments. You do not function without your brain. Your brain does not function without synaptic connections and networks. Synapses do not work without neurons, and neurons do not work without energy and nutrients. Your brain affects every area of your life. So to optimize our life and our creative potential, one thing that we must always do is optimize our neurons' energy systems. How well our brains create energy dictates how well we will manage everything in our lives, including our abilities to create and innovate. If you optimize your brain's energy system, you can increase your ability to create with excellence and innovate with ease. You can increase your ability to do everything. So, how do we do that? Every cell in your body cannot function without energy. Your neurons involve energy, a lot of energy. Your brain takes up nearly 20% of your overall bodily energy. It can burn even more energy when it is performing deep cognitive processing. So, how does your brain get its energy? Your cells make it. Inside every one of our living cells are several tiny organelles called mitochondria. The energy that sustains us is made in these mitochondria. Each one of our brain cells contains several thousand mitochondria. The quantity, health, and efficiency of your mitochondria directly determine the health, efficiency, strength, responsiveness, resilience, and brilliance of you. Your mitochondria provide your brain power. All of it. The body has to constantly make energy on demand, and your mitochondria make that energy. And as any other chemical energy system goes, fuel is needed. Certain fuels are needed for mitochondria to make that energy. Mitochondria use various types of fuels to synthesize a substance called ATP. ATP is the energy of you. It's keeping you alive this very moment. Making ATP is what your cells do. ATP is your brain's energy. Your body can survive a few weeks without food. Your body can survive a few days without water. But if the mitochondria and all of your neurons stop functioning, stop creating ATP, you die in a few seconds. If your body is not fueled well, your cells can experience fatigue. If the cells of an organ become fatigued, then the entire organ experiences fatigue. And of course, your brain can experience fatigue. We've all experienced that. Fatigue is generally not a moral failing, nor is it an absence of willpower. It's an energy delivery problem. The mitochondria are not getting the proper fuel that they need. That fuel comes from A, what you've recently consumed, or B, from elsewhere in your body, be it from fat storage, from your liver, from your muscles, or from elsewhere. All of that is delivered to your brain via the bloodstream. Your brain has more mitochondria than your heart and lungs and legs, so your brain is due a lot of nutrients. Remember those 3 areas of the brain, the human upper brain, specifically the prefrontal cortex, the limbic instinctive Labrador inner brain, and the reptile lower brain? That reptile brain keeps you alive second by second. It keeps your heart beating and it keeps you breathing. If your reptile brain fails, you die. End of story. So naturally, it gets first dibs on blood nutrients and oxygen. That Labrador inner brain keeps you alive, surviving the constant unknowns of that scary and threatening universe outside. Without this inner brain, you have a nearly impossible chance of survival. So this Labrador brain gets second dibs of nutrients from the bloodstream. And your human brain, your conscious brain, your creative and calculating brain, your focusing brain, your cursor of the mind brain, it gets all the leftovers that weren't taken away by the reptile or Labrador brains first. So if your bloodstream to your brain isn't nutrient rich, if it isn't delivering the right types and right amounts of mitochondrial fuel to your human brain, how are you going to create effectively? How are you going to innovate with ease? How are you going to do anything with ease? So set the conditions for limitless energy. And that's not saying eat junk food and monster bull drinks and caramel iced frappuccinos. Some of those things may actually add excessive levels of sugar and toxins into your body, which your cells have to expend extra energy to guard against and remove. Now you see where your energy crashes come from. Rather, take in materials that are optimal for efficient and effective mitochondrial energy function. So your takeaways? Eat and drink good brain fuel, starting now. Keep that human brain, that motor of innovation, energized and thriving. Keep it properly fueled and ready for top performance. Students and early professionals, it's going to take more than a quick stop to the coffee shop to get you properly fueled before you study and work. Those tasty drinks may add some zip to your neurotransmitters, but they are terrible for your mitochondria, your actual power generation. They are not brain fuel. They are brain shock. There's a difference. They may actually cause your cells to burn more energy than they take in. Study which materials make the best brain fuel. The results may surprise you. It might not be dairy creamer that's best for your coffee. You might come to find out that high-quality butter is better for your coffee and best for your brain. Perform great exercise too. To maintain good blood delivery of oxygen and nutrients to the brain, and to remove wastes from the brain, your blood pressure and circulation must be good. Exercise boosts the quality of your blood. Your blood cells and plasma can pack in more oxygen and nutrients when they're well conditioned. They can also pack in more waste when brain cells must be cleaned. Remember that your body serves the existence of your brain, which serves the existence of you. A well-exercised body is a great foundation and a great defender of a great brain. And recognize these core areas of the inner and lower brains and their intricate wiring. They are very reactive and therefore critical to how you can design, how you can make very effective creations, sharpening your ability to truly innovate with ease. World-class designers know how to hone in on the inner parts of the brain to make the best creations. If you want to learn more, please again visit the playlist The Brain on the Innovate with Ease YouTube channel, and of course take your own initiative to learn as much about the brain and cellular biology as you possibly can. And I highly encourage you to learn more about your body's energy creation systems, about ATP, the Krebs cycle, and mitochondria. Try out this book Headstrong by Dave Asprey. This is not a paid endorsement, but the book expresses a great summary of explaining in simple terms how your brain energy works and how you can optimize it. And of course, you can find more information about these topics on your own. It's your brain. Own it. Please stay tuned, like and subscribe to this channel, and look out for the next show. We've explored the brain. Now, let's explore the mind. Thank you for watching today.
I do believe we are destined for great things.